what last year.
It has recorded right now. And so let me do a little official stuff. This is Wednesday, the 16th of October 2013. We are in first period geometry class at the Washington State School for the Blind. And participants are myself, JJ Isaacson, instructor, and Abby, go ahead and say your name.
Abby Griffith.
Abby Griffith.
Angelica Rose.
Angelica Rose. And Stormy, say your name.
Stormy Spong.
Stormy Spong. And we are doing lesson 3-4 in the Geometry Concepts and Applications book. It is in volume 8 of Braille. Good morning, Jessica, or good afternoon or good evening whenever you're watching this video. We're just going to talk our way through this lesson, and then you can watch and listen to it and at least keep up with most of the content. All right, everybody. So we are on this 3-4. It says, what do you learn? We're going to learn to identify and use adjacent angles and linear pairs. So we have some interesting vocabulary to put in our brains today. It says at the very bottom of your page on 110, just the bottom 3 lines, it should say when you bisect an angle. When you bisect an angle, you create 2 angles of equal measure. We already learned that yesterday. Remember that when we learned about an angle bisector?
Yeah.
And bisect means to divide in half. So if we bisect a right angle, we get 2 angles that are what measure? So if we bisect a right angle, how many degrees is that?
45.
It would be 45 each, right?
Yeah.
So because the right angle is 90, and then we bisect it, we get 45. If we bisect a 100-degree angle, we get 2 50-degree angles. Good. So that's what they're saying here is you create 2 angles of equal measure. Those 2 angles are called adjacent angles. The 2 angles are called adjacent angles. So if you turn the page, the Braille page, and then we're just looking at the graphic right there at the top, Angelica. It has a huge graphic in Braille. Oh my gosh! Sometimes it always astounds me that it just depended on who made the graphics in this. Sometimes they make them very small, and sometimes they make them nice and big. We have 3 rays in this particular graphic, and it's creating 3 angles. One big, huge angle that then it has angle 1 and angle 2 represented because it has
have a vertex.
It doesn't. It's not labeling anything.
No.
So yep, there's no labels on this other than it's saying angle 1 and angle 2, because they want to indicate to you that the top ray combined with the middle ray is angle 1, and then the middle ray combined with the bottom ray is angle 2. And angle 1 and angle 2 are adjacent angles because they share a common ray. And the common ray is the one in the middle. Now the common ray does not have to be a bisector, but it has to be a ray in the middle that creates adjacent angles. So adjacent means side by side. So that's what these are, side by side, because they share that common ray in the middle. All right? So we have on the next Braille page, and in your blue box, Angelica,
Got it.
we have definition of adjacent angles. So here we are with our Euclidean geometrist brains on, and we're gonna put into our heads this definition of adjacent angles in our mathy words. So it says in words, adjacent angles are angles that share a common side and have the same vertex, but they have no interior points in common. No interior points in common. And that would make sense. If one angle is next to the other angle and there was a point in the midst of one angle, it can't be in the midst of the other angle. All right? The biggest deal to remember about adjacent angles is that they share the same vertex and they share a common ray. They share that middle ray. And so we have a model for us on this page, and they do label this model with different points. So we have 3 rays. We have a vertex. What is our vertex point?
M, R.
R.
Oh, R.
Mm-hmm.
That's a
R is our vertex point. Okay. And then from R, go through about the 2 o'clock position, and you go through what point?
J.
J. Good.
Where's J?
And from R, go through the 2 o'clock position. There you go. Okay, at J. So that's RJ, right? RJ, that's Ray RJ. Now go back to R and go through about just before 3 o'clock. Through what point?
M.
Good. And that's Ray RM, right? Ray RM. And then go back to R and go through about the 4 o'clock position through what point?
N.
N. Good. RN. Okay, Ray RN. So we have 3 rays. RM is the one that's in the midst of it, isn't it?
Yes.
It didn't give us that it was a bisector. That's okay. It's just in the midst of it. So it's created this common ray that 2 angles share. The angle on the top, if I want to like have a position for it, would be angle JRM, right? JRM, or we could name it MRJ, or we could name it angle 1, right?
Yep.
Okay, so that angle is adjacent to the angle on the bottom that is MRN or NRM or angle 2. And they share the common ray RM. So they're adjacent. That means they're side by side. Adjacent angles, side by side. Okay? And it also says in words down below, our drawing, and to the right on your print version, Angelica, it says angle 1 and angle 2 are adjacent with the same vertex R and a common side, ray RM. Okay? So that's a definition of adjacent angles. This is super important. This is going to help us with a lot of things in the future to solve some problems, to be able to prove some things. So we want to make sure we're really clear about what it means to be adjacent angles, side-by-side angles. All right. So we're going to turn the page and practice this adjacent angle definition with some different drawings. So on 110C,
Right angle.
it says determine whether angle 1 and angle 2 are adjacent angles. So we got to take a look at a drawing very, very carefully and decide whether angle 1 and angle 2 are adjacent. So this particular drawing, we have a vertex K. That's the only point they're labeling on this drawing. But they are labeling 2 angles. They're labeling angle 1 and angle 2. So what you do is you find your K and you follow the rays that create angle 1, and you're like, okay, I have my angle on the left there. It's got that. And then you go and you find angle 2, and then you go back to your vertex. You follow the rays that would create angle 2. And then you need to decide, based upon the definition of adjacent angles, whether these 2 angles are adjacent or not. What do you think?
Yeah.
Do they share a same vertex? Well, yes, right? But do they share a common side?
No.
No.
Oh, because
They do not share a common side. Do you see that? Yeah? Do you see it, Abby? They don't share a common side. This angle has these 2 rays happening for it, and your right angle has these 2 rays happening for it. Okay? Stormy, do you understand what's happening here?
Yeah.
Okay. So we have 2 angles that are separated by an angle that they didn't label. There's an angle in the midst of them. So these are not adjacent angles. They only meet one piece of the definition of adjacent angles, so they're not adjacent. All right, turn the page, Braille users, and then, Angelica, we're looking at the next drawing down.
Yeah.
Okay. So we have 2 lines here that are intersecting and creating several angles.
Whoa.
Yeah, see that? They're intersecting and creating several angles. And what happens when 2 lines intersect? Where do they intersect at? The point, right, Abby?
Point, yeah.
Got your fingers right on it, and they intersect at the point. Yeah, the point P. Yeah, two lines always intersect at a point, and this is at point P. So point P is our vertex. It's our vertex of several angles. They've labeled angle 1, which is the angle, I'm going to say the top angle. Okay, we'll just say it's the top angle. And then they've labeled angle 2. All right, find that? Okay. Now, so if you concentrate on and say, okay, well, are angle 1 and angle 2 adjacent angles? Well, do they share a vertex?
Yeah.
Yes. Okay,
Yes.
we got one criteria handled. Do they share a common ray?
Yes.
Yes, they do. They share a common ray. That ray going up right through the midst of them, don't they?
Yeah.
So angle 1 and angle 2 are adjacent. You're going to learn here in a minute that angle 1 and angle 2 are also a linear pair because they're two angles that are adjacent to each other, and the base of them is a line. It's a line that has opposite rays.
That one?
So not that one, this one right there, right? Because you have angle 1 and angle 2. They share this ray, and it's going to form this line here. Those are called linear pairs because together they combine to form this linear line. They have opposite rays that form a line. But we'll get there in a minute. Hold on, right? Okay, let's go to our next graphic.
What about this? We didn't do any.
Yeah, there's nothing. That was just extra information.
Oh.
They didn't label those other than they labeled the vertex P. But the bottom angles are also adjacent. There's several adjacent pairs going on all the way around that drawing. All right, turn to page 110E. And Angelica, we're one more drawing down. Yep. Okay. All right, we got to take a real close look at this. So we have an interesting thing. We have a line at the top. Well, actually, it's a ray, isn't it? We have a point M on the left. And if you go immediately to the right, it goes through 2 points, point T and point L. So we have this ray, ML, at the top, all the way across the top, ML. You're okay. ML, all the way across the top. Okay. And it goes through 2 points. Goes through T and then goes through L. All right? How you doing, Stormy? Okay?
Yeah.
Okay. Then we go back to M, and if you go, you can go diagonally immediately down through about, there you go, through about 4 o'clock or so. And then you go back up to T, and you go diagonally down, parallel. That's what's happening is parallel. All right? So we have some very interesting things going on here. So
are we looking for that one?
Well,
or this one?
I know. Let's take a look. Let's go back to M,
Mm-hmm.
and I want you to trace along the angle that goes. So you're going to go through L, so immediately to the right through L, all the way through L, all the way, all the way, all the way. All right, back to M. All right, now then down diagonally.
This way?
Yeah, just through. There's no point there.
No.
That's an angle. That's angle 2 they're labeling. So that big angle is angle 2. Now go to T and go through L. So immediately to the right through L, then go back to T, and then go down diagonally. And that's angle 1. All right?
Mm-hmm.
So are angle 1 and angle 2 adjacent angles? Think about your definition of adjacent angles. Do they share the same vertex?
No.
No. We can throw this out right away just because they don't share the same vertex, right?
Oh, yeah. Angle
Yeah.
1 has the T
Uh-huh.
vertex.
Yes.
Angle 2 has the M.
Angle 1 has a T vertex, angle 2 has an M. Bah! Already it violated the adjacent angles definition, didn't it? They don't share the same vertex. Then they also don't share a common side, do they?
Nope.
No.
They do not share a common side. They break it up. Angle T or angle 1 has its little TL ray and then its little T whatever ray. They didn't put a point out there. And then angle M has its ML ray, and then the one going down diagonally that they don't have a point to share. Now, they share a little piece of, ML shares a piece with TL, but it doesn't share the whole side. And that doesn't, you can't share a piece of it. That doesn't count. But just by them not sharing the same vertex, we're able to throw it out. Okay?
So you just didn't.
Yeah. You're able to say, no way.
That kind of looks kind of cool, though.
It does. Well, later you're going to learn that that's two parallel lines with a transversal. And actually, angle 1 and angle 2 are congruent. You're going to learn that. You're going to learn that when two parallel lines are intersected by a transversal, the corresponding interior angles are congruent. You're going to learn that later. It's kind of cool. All right. Turn the page and we're going to practice this. Our turn, it says your turn on page 110F. There are two drawings on 110F. On Braille's, Angelica, you do have three drawings, one right after the other. A, B, and C, little a, little b, little c. The drawing at the top of F110 in Braille is two lines intersecting. They've labeled two angles. The top angle, they've labeled angle 1, and the bottom angle, they've labeled angle 2. Are these adjacent angles?
No.
Yes or no? Are they adjacent angles?
No.
No. Why are they not adjacent angles?
Because
We don't share the same side.
They don't share the same side. Yes.
they're turning this way.
Yeah, Abby. Yep. And Abby's putting her hands on her paper and saying, well, one goes this way and one goes that way. And in mathy terms, Stormy, you nailed it. You said they don't share a common side. They don't share the same side. They don't share a common ray. They're just hanging out there. They share a common vertex, right? That one in the middle.
Yeah.
But they do not share a common side, so they can't be adjacent. These angles are actually called vertical angles. Yeah, vertical angles, and you're going to learn later that vertical angles are congruent.
That's kind of confusing. Because it says this one is, that one's not.
Correct. But look, so Angelica's pointing at her drawing and saying it's kind of confusing because they're saying this one is and this one's not. She's looking back at example 2. But they labeled 1 and 2 side by side right here, sharing this common ray. Look what they did to you here, 1 and 2. Does that help?
Yeah.
Okay. Good that you kind of looked at that and went, wait a minute. These look the same, but they labeled two different angles. All right, letter B, little letter B, is your next drawing on this page, F110. It's down below. And you have a straight line as a base, and then a ray going up diagonally from the middle of it. And they've labeled the angle to the left as angle 1, and the angle to the right is angle 2. And Abby says, oh, this is adjacent. And why is this adjacent?
Because they share,
Because they share what?
side.
They share two things they have to share.
And
Vertex.
The vertex
And common side.
and common side, yes. And these two, again, we're going to learn here in a minute, these two angles are linear pairs because the two angles come together and their opposite rays at the bottom form a line. Isn't that cool? All right, so this is a yes. Okay, Braillers, turn the page to G110. All right, and you were immediately looking to the right and go with that little letter C.
Yep.
Okay, we got two angles. We basically have two angles floating out in space here. Angle 1 and angle 2. Are these adjacent angles?
No.
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 What did they do, though? This is a little trickery on this drawing. They put them kind of side by side, didn't they? I mean,
Yeah.
they look like reflective images of each other, mirror images of each other.
Look.
But, yeah, and their little arrowheads are touching a little bit. But they don't match the rule, do they? They
Yeah.
don't share a common vertex. They each have their own vertex. And they don't share a common side. Even though the sides are side by side, they're not the same side, are they?
Nope.
So this is a little bit of trickery. Some students might say, oh yeah, they are, because they look the same. They're right next to each other. Doesn't mean that it's two angles floating out in space next to each other. Adjacent angles have to be sharing the same vertex and sharing a common side. All right? Okay, you Euclidean geometrists. You have a page break on this page for page 111. Finally, Angelica, you get to look at a different page. Page 111 at the top of your print page. And now we're going to talk about just what we were saying, that in example 2, the non-common sides of the adjacent angles form a straight line. These angles are called a linear pair. And so the definition of a linear pair, so we got to turn the page, Braille users, to A111. That looks kind of fun. A111. Little dots all in a row there. All right. Definition of a linear pair. All right, we're going to put our Euclidean brains on and really think about this. Two angles form a linear pair if and only if, a biconditional statement, if and only if they are adjacent and their non-common sides are opposite rays. Aha! Now this is tapping into things you have learned in previous lessons. First, the if and only if, biconditional statement. Secondly, you had to learn about adjacent angles, and you just learned about that. And third, you had to learn about opposite rays. That was 3 lessons ago. Opposite rays share an endpoint, and then they head in opposite directions. One goes through 9 o'clock and one goes through 3 o'clock. That's one version of it. It's always in opposite directions. So one could go through 8 o'clock and one could go through 2 o'clock. One could go through 6 o'clock and one could go through 12 o'clock. Okay? It's always opposite. And so they're basically, what they're doing is they're cutting. If you think of a clock, it's the diameter, right? The center is the endpoint they share, and then one hand is going through like 10 o'clock and one hand is going through 4 o'clock. They're always cutting our circle in half. That's a line, isn't it? And when two angles are side by side on that line, they're an adjacent pair because they share a common ray, and they're a linear pair because they're combining to create this line, right? These opposite sides. So they give a drawing, and they have a line at the very top of the drawing. They actually have some points labeled here that we can make our way through. B is your vertex point, and then immediately to the left it goes through point A, so you have ray BA, and then immediately to the right it goes through point D, BD. Those are opposite rays and are forming your line. Then go back to B and go through about the 8 o'clock position through point C, and that's a ray. And then they've labeled angle 1 to the left and angle 2 to the right. So we have our adjacent angles, and they are sharing these opposite rays. These non-common sides are opposite rays, so these are linear pairs. Angle 1 and angle 2 are a linear pair. They're forming, and their sides, their non-common sides form a line. Linear line. Okay, does that help?
Yeah.
We're gonna go through now. If we haven't learned this yet in this lesson, it's going to come up here in a lesson or two. But let's just put our brains on and think about this. How many degrees is a line? Like if we go from one side of our line all the way to the other side of our line, how many degrees is that? Not 360, you're close.
180.
180, it's 180. If we did 360, we would go all the way around like a circle. But if we just go from one side and we stop at the other side, we've done 180. So if you go from point A and then you just loop over to point D, and don't go back to point A, just go loop over to point, you've gone 180 degrees. Okay, so you take point A and you just go wee, we point over to point B. That's 180 degrees, right?
Yep.
Did you understand that, Stormy? The wee?
Yeah.
Okay. All right. So we've done, so a linear pair, we're going to learn this later, but we can think about it now. We're smart. We're Euclidean geometrists. It's making 180 degrees. So if I said angle 1 is 60 degrees, what would you tell me angle 2 is?
Same thing?
No, it's not. They're not congruent. They're a linear pair. So if I said angle 1 and angle 2 are a linear pair, and angle 1 is 60 degrees, 120, Abby, that's right. Yep, because we'd have to get to 180. So whenever you're looking at linear pairs, the two angles are going to have to make 180 degrees. You're going to learn that later in an official lesson, but we're just putting our brains on and thinking about it right now. All right, let's go do some practice. So turn the page, Braille users, to B111. Angelica, we're looking immediately down below your definition of linear pairs. There's a drawing to the right. It's got 1, 2, 3, 4, 5 rays going on officially. Now this is always interesting. They had a few pages back a huge angle with 2 rays taking up the entire page. And then now they've squeezed in a whole bunch of angles on this page, right? But we'll work it. We'll work it out.
The vertex is C?
The vertex is C.
Okay.
That's right. The vertex is C. And we have a bunch of rays going on. If you go to C and you go through about the 7 to 8 o'clock position, you go through point M. So to the left through point M. So you have CM. Go back to C. And you could go the opposite direction and go through point E, and your brain should turn on and go, oh, CM and CE are opposite rays. Okay, ding, ding, ding. All right, and then you go back to C and go up through about the 10 o'clock position, and you go through point A. So we have ray CA. Go back to C and go up through about the 11 o'clock position, and you go through point T. Ray CT.
I thought you don't say vertex point first. You have to say AC.
No,
Oh, yeah,
CA, you gotta
because
say,
of ray.
yeah, it's a ray. Then go back to C and go up through just past the 12 o'clock position through H. And you have CH, ray CH. So they've labeled a bunch of angles on this drawing. Go back. Go find M, which was immediately to the left, and go MCA. MCA, angle MCA or ACM. That is angle 1. They've labeled it right in the midst of it in the interior, angle 1. Then go to A, so find A, and go back to your vertex C, and go up to T. So CAT, haha, angle cat. Angle cat or angle tack, right? Because we could also name it T, oh, excuse me, cat, ACT, act, not cat, ACT, act, or TCA. That's an angle. They've labeled it angle 2 in the middle of it. The Braille is a little funky because some of it makes itself on the line. All right, go to T. Now go down to C and go up to H, which was just past the 12 o'clock position. There's another angle. That's angle 3. We've labeled that one angle 3. All right, now go.
They put
yeah, they put the nemeth and it kind of goes over the line. All right, go up to H again, just past 12 o'clock. Go back to your vertex C and go through point E. So we have HCE or ECH. That's angle 4. All right? Etch. Yeah. So we got all these 4 little angles labeled. Now they're saying in writing, it says in the figure, ray CM and CE are opposite rays. And we discovered that when we were looking at it, didn't we? CM and CE are opposite rays. Name the angle that forms a linear pair with angle 1. All right. So we got to go find angle 1. All right. So there's angle 1. Abby's got her fingers on it. Find angle 1, Stormy?
Yep.
All right. And it is MCA or ACM, isn't it?
Yep.
Okay. So it's part of our linear pair what is the angle then that is adjacent to that angle that forms the linear pair? So we have an angle that's adjacent immediately to it is ACT, right? That's an adjacent angle, but that's not a linear pair. The big, huge angle ACE. ACE. So it's actually angle 2, 3, and 4 combined. That's the angle that forms the linear pair at angle 1. ACE.
Ace.
ACE. Do you see that, Stormy?
Yeah.
Okay. So this is kind of trickery because they put a whole bunch of angles in there, and then you had to make your way through this and go, oh, well, I've got angle 1, and I got to figure out the linear pair. Angle 2 is only an adjacent to it. I got to combine 2, 3, and 4 to get my linear pair, because my linear pair has to be the angles that form that line. So to get 2, 3, and 4, I actually am coming from point A back to C and then all the way over to E again. The deal is, to find your linear pair, just go opposite your vertex and get to that point at the end of your line, and then go back and grab that common ray.
Yeah.
Because their common ray is CA. So if you knew that it was MCA or angle 1, then you knew, okay, I've got to have CA as my common ray, and then I'm going to go opposite my CM ray and just go out on that line and find E, and that is my linear pair to the side to angle 1.
The centimeter ray.
What's that?
The centimeter ray.
Yeah, the centimeter ray. Yeah. All right. Then it asks for example number 5, do angle 3 and angle TCM form a linear pair? Justify your answer. So we have to find angle 3. That's a little angle. It was TCH or HCT. It was the one kind of in the midst there. H was just past 12 o'clock. So HCT. That's angle 3. And it wants to know if it forms a linear pair with TCM. So we find T, we go back to C, and we go to M. So is TCM and angle 3 a linear pair?
No.
No. Why, Angelica?
Their non-common sides are not opposite rays. And
Good job. Their non-common sides are not opposite rays. That's exactly what it is. Nicely done. Nicely said. Mathy words. Non-common sides are not opposite rays. They share a ray, don't they? They share TC or CT, right?
Yeah.
So they're adjacent because they share the same vertex, C, and they share CT, but they're non-common sides. So CH and CM, those aren't opposite rays, are they? CH and CM. The only way we can get opposite rays is to have CM and CE. Nicely done. All right, little letter D says to name the angle that forms a linear pair with angle MCH. MCH. So MCH. So M, you know, is out there hanging off to the left. You go back to your vertex C. You go up to H. All right, you got your angle there. Now, what's your linear pair to MCH?
CHE.
Name it. Yeah, there you go. What do you want to say, Angelica?
HCE.
HCE. Good. You corrected yourself. You started to say it with the vertex,
Yeah.
right? But you always want to say the vertex in the middle.
Yeah.
HCE, or we could say ECH, or we could also say angle number what? 4. So Stormy, what is so if we had our original angle MCH, we have the vertex C. What's the opposite ray to CM?
opposite ray.
So,
You got CM. What's opposite?
that one, E.
Yes, CE. Good.
Opposite, straight
CE.
opposite.
And their common side
C.
would be CH. CH. So that's how you find a linear pair, is you just say, okay, I know that the common side has to be that middle ray.
Uh-huh.
Go back to your vertex and you find the opposite ray. And that would be CE, so that then you would know you have HCE as your linear pair to MCH. All right? That's kind of
Okay, yeah.
trick. That's the trick. That's how you have to do it. Linear pair is all about finding the common side and the opposite ray. Common side and opposite ray.
Okay.
All right. So let's see. We have to tell whether TCE and TCM form a linear pair. Oh, well, I already hear something in common. Angle TCE and angle TCM
TC.
form a linear pair. So Angelica here's TC. What is TC? What's that? What is TC?
That's
In relation to these angles, what would you say TC is?
the
Or CT?
common.
It's the common ray, isn't it?
Yeah.
Okay, so we've got a common ray. Ding, ding,
Yeah.
ding. That's a good thing, right? We've got a common vertex. Ding, ding, ding. That's a good thing because we know they're adjacent. They got to be adjacent. Now we got to figure out, are they linear? So what's the final rule on a linear pair?
Opposite rays.
Opposite rays. Do they have opposite rays?
Yes.
TCM and TCE.
Yep, they do.
They do. What are their opposite rays?
ME.
The CM and the CE. That's right. Okay? So 3 things happened and we were able to diagnose and figure out. We heard the TC part, right? The CT
Yeah.
part. Well, first, what you should do is listen to angle TCE and angle TCM. Just listening to that, what's their common vertex? C. So you're like, okay, I got a common vertex. That's a good thing. All right. Then I listen to angle TCE, angle TCM.
They're on the opposite
Oh,
sides.
I've got CT going on here with a common side. And I can go look at that on my drawing. And then I go and take a look at the other rays, the non-common side, and I've got CE and CM. And I take a look at my drawing and go, oh, bing, 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 those head in opposite directions. I've got a linear pair. All right? Is that helpful?
Yep.
Oh my goodness, would you ever thought of looking at drawings as being so convoluted?
How logical.
All right. The next example is ridiculous. We're not even going to do it. I don't even know. Let's look at the tactile. I don't even know if they give you. Yeah, they give you a tactile on page 111D. You can go look at it and laugh. There is so much going on this tactile that I don't even know how to explain how to figure out what you need to look at. It's on 111D. You can look at it and giggle. What they tried to do was draw a picture of the John Hancock Center in Chicago. And it's got a bunch of kind of scaffolding kind of things going on, and they wanted you to identify the angles, which would be really cool, but they didn't make it super clear as to which angles you're supposed to be identifying. They did put some arrowheads on one of them, but it's not very easy to make out. So, yeah, what the heck? It's just a whole bunch of texture going on and
Okay.
lines.
On this book.
Yeah, it's much easier in print because in print
It's red.
they put red on the 2 angles that they wanted to look at to
Poor blind
indicate
people.
a linear pair.
What the
So
heck?
I know. We just
How would you even...
Put arrowhead here actually.
they did put a couple of arrowheads to try to help you, but that doesn't really help, I don't think. So.
No, it doesn't.
All right. The next couple pages are discussing graphing calculators. We don't work with that stuff in here. It's not really super necessary. You're going to work with graphing calculators in Algebra 2, and you will work with them in college. You'll probably work with a graphing calculator on a computer But no worries in this class. We don't do a lot of work with graphing
worry in
calculators.
a college when
Yeah.
that's all good.
So they have a couple pictures on 112A. They show a picture of the graphing calculator, and then they have a whole bunch of directions on 112B. And then finally we get to check your understanding on 112C, I believe. Is it 112C? No, hold on. Yeah, 112C. Okay. Then we want to turn to 112C. Okay, 112C. Yes. All right. We got use the terms adjacent rays, linear pair, or neither to describe angles 1 and 2 in as many ways as possible. So they have two drawings on your page 112C. So your first drawing is kind of right in the middle of the page. And they don't have any, they are not labeling any points. So you just got to kind of make out where your vertex is. You have a line, and then you have a ray coming off the line diagonally through about 10 o'clock. And they've labeled the angle to the left, angle 1, and the angle to the right, angle 2. So these two angles,
112C.
are they adjacent angles, linear pair, or neither? Angle 1 and angle 2. They're adjacent, okay, and what else are they?
Linear.
Linear, yes, Stormy. They're adjacent and linear. Yep, because why? Because they form a line, exactly. They have a common vertex, they have a common ray, and then their non-common ray, as Angelica stated earlier, their non-common sides are opposite rays, aren't they? So angle 1 and angle 2 are both adjacent and linear. Linear pairs will always be adjacent. Adjacent pairs will not always be linear, but linear pairs will always be adjacent.
It's kind of confusing, so don't confuse the two.
Correct. But it's kind of like, you know, numbers that are divisible by 9 are also divisible by 3, but numbers that are divisible by 3 aren't necessarily divisible by 9, right?
Yeah,
okay?
3
So,
divided by
yeah.
9.
So the linear pair is always adjacent, but an adjacent pair is not always linear, correct? So the converse is incorrect. Okay. All right. How about the next drawing? So right below that drawing, right at the bottom of your page.
Adjacent again.
They're adjacent again. Exactly. What's the rule for adjacent? They have to share what?
Same vertex.
They have to share the same vertex. And what else do they have to share?
Common
A
side.
common side. And so that ray right in the middle is their common side. So these are adjacent, but they're not linear, are they? Because their non-common sides are not opposite. Yeah. Excellent. And the bell's going to ring. You guys did an awesome job. Nicely done. If you'd like to do a smidge of homework, you could try number 8 through 13, and that would be really good practice for you. Number 8 on page 113. Page 113, number 8 through 13. That would be really good practice for you.
8 through 13. Do you have a mark? I am on the right
You
page.
You want to put it in there? Is that number 8 right there? Or no?
Not
that's
8,
number
but
6.
113.
Yeah. Got to turn a couple pages. Yeah. There you are, right there. All it is a whole bunch of drawings of angles, and you have to identify whether they're adjacent, linear, or neither. Okay? And you need to say why they are. Okay? That's what they want you to do.
8 through 13. Okay.
8 through 13.
Can I pick up later?
Yep, you may pick it up later. Yep, we'll put a marker in there, put a piece of Braille paper in there. There you go.
Thank you.
All right, my dears, have a fabulous day. Jessica, we hope you're feeling better. Enjoy listening to your class today and learn some information. And we're going to turn it off now, all right?
Yep.
See you tomorrow.
See you tomorrow.
See ya.
Okay.